In this video, we're going to continue our discussion about entity relationship diagrams. Specifically, we're going to focus on attributes. So an attribute is a property or characteristic of an entity or relationship type. We'll talk about what a relationship type is later on. However, in the previous video, we spoke about what is an entity. So here are three entities: department, employee, and course. So we would identify some attributes that relate to each one of these entities. So department, we have department ID and name. Employee, we have employee ID. We have name, which is represented by first name, last name, and in some cases even middle name or second last name. We have phone, we have address, which has many pieces such as street, city, state, and zip code. We have email, we have salary, and we have date employed. For course, we have course ID, title, and description. All of these are characteristics of these entities, and we can use data to represent these characteristics. So let's talk about specific types of attributes. First, we have simple versus composite. A simple attribute is the attribute that stands alone. So to better illustrate this, let's talk about what a composite attribute is. A composite attribute has an attribute with meaningful component attributes. So if we look at this employee example, we have name that has multiple components that make up the attribute. So first name and last name together make up the name. So this is called a composite attribute. Address also falls into this category. So all the other attributes that are represented here are simple attributes. The next type of attribute we're going to talk about is the multi-valued attribute. A multi-valued attribute may take on more than one given value for a given instance. Take, for example, this table on the right side of the screen. You see here that we have three rows: employee ID 1, 2, and 4. If we go to the skill column, you'll see that we have multiple skills represented. So Phil Morris, for example, has the skills of bandsaw, table saw, router. Lawrence Haley has 2 skills, and Laura Ellenberg have 3 skills. So if we ever have data that's represented as multiple values in a single cell, we can represent it in our entity relationship diagram using these curly brackets to illustrate that this is a multi-valued attribute. However, be cautious about using multi-valued attributes. I would argue that creating a separate entity for skill makes much more sense in this case. But if you were to represent your data with a multi-valued attribute, this is how you do it. The next type of attribute is the derived attribute. Now, the derived attribute is only shown in the entity relationship diagram stage of preparing your database because derived attributes aren't actually stored in the database. Rather, it's just to kind of indicate that this is a query that we'll eventually want to run against our database. So what is a derived attribute? It's basically values that can be calculated from other related attributes. So for example, we have here years employed. How would we know how long an employee has been employed based on attributes that we already have? Well, we can go to the date employed attribute. So we could take the current date, subtract when the employee was employed, and then we could figure out how many years that employee has been employed. You'll notice that derived attributes are represented with square brackets around them, indicating that we will ultimately not have this as a column in our database when we finally implement it. Additionally, we can have required versus optional attributes. Required attributes are anything that must have a value for every single record that is put in the database. So as you can see here, most of these are going to be required. Optional means that they don't have to have a value for every single instance. So for example, not every employee is going to have a fax number. In fact, who uses fax numbers anymore these days? It's crazy when I get a company that asks me to fax something over to them. I'm like, where do I find a fax? Anyway, so you could represent that an attribute is optional by just putting the parentheses O after the attribute, indicating that this does not have to have a value for every single record that is stored in our database. So if I were to show you this table where we have all the attributes representing a student in the left column, student ID, student name, street, city, state, zip code, and major, which of these would be required and which one of these would be optional? If you said that major could be optional, then you are correct, unless you say that undeclared is considered a value and must be stored in the database. Then this would not be optional and must be required, just like every other piece of the database. You may also argue that some of these other attributes are not required, and that really depends on what you are collecting the data for and what information you actually need to have stored in your database. The next type of attribute is the unique attribute. This is an attribute where every single value in that column, or every single value for every single instance in that entity, is different from every other value. So looking at the employee entity, which of these must be unique from every single other value that is stored in the database? Well, it's going to be employee ID for sure, because you're never going to want to have two employees with the same ID. You may argue that phone and email could be unique, but at the same time, I know a few people that share the same phone number. I know a few people that share the same email address. So I would argue that these are not unique attributes. So we would have one unique attribute. But the idea here is that we need to go through and identify all the attributes of an entity that could potentially be unique. And if there isn't any that could potentially be unique, then we have to create our own, because every single entity must have at least one unique attribute. And these unique attributes are called candidate keys. Ultimately, one of these attributes will become our identifier, which in this case is the employee ID, which we are going to represent using an underline. So what is an identifier? An identifier is an attribute, or even a combination of attributes, so it could be a composite attribute, that uniquely identifies individual instances of an entity type. So, for example, simple identifier, if I give you an employee ID, I will know all the information for that employee based on looking across the row that corresponds to that employee ID. We can also have composite identifiers. As you can see here, we have flight number and date time together represent our identifier for the entity flight. Now, why can't flight number alone be the identifier? Well, a flight could take off from multiple locations in a single day, and so we would need to know the date and the time that it took off so that we could capture this information. Additionally, we could also have a candidate identifier. These type of identifiers are those that exist because they already are attributes of that entity to begin with, rather than having to create one. For example, people don't come along with an employee ID. They come along with a social security number if they are located in the United States, but they don't come around with an employee ID, and typically an organization would assign these employee IDs to that employee. Whereas a candidate identifier means that it already comes with some kind of unique attribute that's going to represent every single record. So for example, a book, unless you're the publisher that's actually creating the book, a book is going to have an ISBN associated with it, and so we can just use that as our identifier for that entity. So now what I want you to do is identify possible attributes for the following entities that we previously identified. So go ahead and pause the video, include the attributes, and then come back to compare your answer. All right, welcome back. So let's start with coach. So when we're looking at a coach, we obviously know that each coach is going to have a name. So we would capture the first name and the last name. I'm just going to abbreviate L name and F name. And then we could have hometown or where they were born, etc. Now, if I were to ask you, if I have the name of a coach, is that going to be unique for all coaches that exist in our system? Maybe, but if there's ever a chance for a duplicate, then that's not going to work. So what we want to do in this case would be to create our own identifier. So I'm going to call it coach ID, and I'll just go ahead and underline this. So we have an identifier, we have a composite, and a simple attribute. Let's go to player. So player, we have player number, we have name, so first name and last name. We could have shots, rebounds, assists, field goal percentage, etc. Now, these shots are going to be a total for however long that player has played. So across all years, all seasons, that's going to be a representation of that. So that means that these shots are going to be derived attributes. Same goes for rebounds, same goes for assists, same goes for field goal percentage, etc. There's quite an array of values you could have identified here. Now, let's think about this. Is player number a unique attribute for all players in the system? We're not just talking about a specific team, but for all players. Even on a specific team, that's not the case, because someone may have had that number on that team and then moved to a different team, and now they have the number again. So player number does not uniquely identify each player. So in this case, we again want to create a new attribute that is going to be our identifier, and in this case I'll call it player ID. All right, so let's go to game. Let's go to the game and identify a few attributes. We could have home, we could have away team, so these are the two teams that would be playing in that game. We could have start time, we could have the date of the game, we could have the location of the game, and many other attributes. Now, could any of these be our identifier? Well, if we were to do start time and date together, would that be unique? No. If we did location, date, and start time, yes, that could be our identifier with 3 attributes. But for simplicity, let's just go ahead and do game ID to create that as our identifier. All right, so let's go over here to season. So season, we could have the year of that season. We could have the MVP for that season. We could have the champion for that season, etc. Now, this MVP could be optional because at the beginning of this season, we don't know who the MVP is. Same with champion. We don't know who the champion is for that season. Now the year, you may argue whether or not that's the identifier. Now if you include the year just as like the start year, then that could be a unique attribute that you could use as the identifier. Basketball seasons typically span across 2 years, so that's something to take into consideration. So I'm just going to go ahead, just like what we did before, and create a season ID. Now, just because I created an attribute for each one of my identifiers doesn't mean that's always going to be the case.